wonderful assistance there as well.
So that's terrific. Much appreciated. Thanks so much. Look into that. Okay, so ladies and gentlemen, we're going to now we're going to put in place a set of mechanisms whereby individuals could evolve over time. So specifically, we're going to put in place a kind of theory of personhood that involves two elements. One will be weight, current weights and weight evolution over time, and then we're also going to have in place a classification as to someone's diabetes status. Okay, so their glycemic status. So I would like to modify this model so that our theory of personhood is enlarged. Where do we go in this model to modify our theory of personhood?
The person.
To go to person, indeed. Yeah. So let's go to person. Okay, and within person, ladies and gentlemen, we're going to do something we haven't done before. To wit, we're going to go. Bless you. Well,
this ain't nothing to sneeze at.
Yeah. So here within person, we're going to drag in a state chart entry point, which should be. We're going to call it diabetes state chart. Okay. So I'm sorry. So we went to person, and within person, we went to over here in the palette, went down to this area called state chart. Now, it turns out these mechanisms, in general, mechanisms in any logic are often exposed at multiple palettes, or some of them are. We could also do it from an agent palette here, okay? That's also possible. But from the, Winchell and Ellen? Ellen? Someone needs help here? Yeah.
Oh, there it is.
Okay.
It wasn't wanting to let me edit the name.
For this state chart palette, okay? Diabetes state chart. Are we okay with that? Okay. And we're going to put in place a normoglycemic state, and we're going to put in place a. So I dragged in first an entry point called diabetes state chart. Let me go illustrate. I'm going to go a bit slower with this, just so you could see in gory detail what I'm doing. So for person, I'm going to drag in the state chart entry point, and I'm going to call it diabetes state chart. Okay. Now, having done that, this is going to be our entry point to the state chart. Now, right now we're going to have it pointing to just one state. Later we'll be seeing how you can distribute among multiple states, but I'm trying to teach the basics here. So we're going to go over to state here, and we're going to make this normoglycemic. Now, when I drag that in, there was something I did that you will want to be very conscious of. So I'm going to drag in a state, and you'll notice when I'm dragging it that there's this little thing at the end of the entry. And right now that thing is white because it's not connected. But if I drag it in a way where it will connect, it will turn it to green. That's an indication that a connection will be made were I to drop it now. Okay? So you'll notice as I move this around, now it's green. If I drop it anywhere in this area where it's green, it will do put in place a requisite connection. So I'll drag it here, and I will call this normoglycemic. Now, I tend to give states a name which is capitalized. Okay, I tend to be careful about my conventions so that when I look at a name, I often know what it is. Transitions I often make lowercase. It's not particularly privileged, but it's handy for having a clear convention, because then you can search for things, you can see a name and have a good sense of what it is, look in a list for names easily, etc. Okay, so ladies and gentlemen, having done that, you'll notice that when I did that and typed that name, it's placing it, but not necessarily in the most aesthetically desirable way. I can move, you notice it's underlined, so I can move that name around. If I want, I could put it outside here, or I could put it in the middle. In different cases, I'll use different placements of the name, but I'll place it there in the middle. Okay. Normal glycemic. Okay. Next, I would like to create a state that is going to be called diabetic. Okay. And we're going to drag this down. We're going to call it diabetic, and initially it will be disconnected. But I want to have a transition go between them. So I'm going to drag a transition from over here down to this diabetic state. Okay, I'm just adjusting that name. And notice when I drag that transition, at least in my case, it can't quite bridge. So that's okay. I'll leave it docked on one side and drag the other side so that it reaches it. Let me show that again for anyone who missed that. I'm dragging in a transition. In general, you won't be able to get it to connect up front on both sides. If you're lucky, you will, or if you plan their spacing very carefully. But I'll leave it connected on one side, as indicated by the green, and then I'll drag the other side to it. Okay? These transitions will characterize the routes of possible change in state between individuals. So a state chart will characterize the states a person can be in and under what conditions a person will change from one state to the other. So that's going from normal glycemic to diabetic, and that's going to be a single direction. Notice when I select one of these, I can use the arrow keys to move it around, which is kind of handy. Alternatively, I can drag it. It just can be a little bit more cumbersome sometimes. So I'm using the arrow keys. Okay? And we're going to leave that initially as a default type of transition, which is a timeout of 1 year. Okay? Okay, ladies and gentlemen, I would like to now go and run this model. Okay? So build the model. Make sure it's a happy camper. Note if you have a hanging transition, it may be an unhappy camper. You may give errors here where it says hanging transition, and you'll want to fix those. Go look down at the bottom for any signs of errors. If there's an error, like something's not properly connected, it will warn you often with this errors, and you can click on this to see the errors. The error messages, okay? So if you have errors, like it's not connected, you'll want to make sure it's connected. So please build. Make sure you don't see signs of errors. If you see signs of errors, Alan is ready to serve there, okay? Okay, next, if it's okay, I'd like you to go run this model. Okay, here we go. And how could we go inspect these people to see what state they're in? Anyone? Yeah, we click on the drag down and we could go see. And we see this person is diabetic. This next person is diabetic, etc. Now we could stop, and let me show you how to run this model. Running models and observing the behavior is one of the keys to kind of developing confidence that the model has that it's not doing something totally different from what you intended. So ladies and gentlemen, I stopped the model. I was running it, and then I stopped it. I came back here. And one thing that's very useful is in this initial screen, you can often set many things up here. So one thing you can do in this initial screen before pressing run is you can set the speed of the model. Okay? This will speed it up. This will slow it down. Or you could use virtual speed mode where it will go as fast as it can. Okay? That's this one here. So that's useful. Another thing is, and this will reset it to speed 1. Another thing that's useful but underappreciated has to do with these two buttons here. For the most part, we've pressed run and just let it run, but you'll notice that you can actually tell it to run it until a certain time or run it for a certain number of time units from now. So we could say, for example, run it for 0.5 time units, okay? And we could incidentally choose our time units if we don't want to just use the default model ones. So we could say run it for 0.5 years. You'll notice the time is not yet started down here, hence time dash, and we could press this. Run for, okay, hey, okay, run for there we go. And now it's run it till time 0.5, okay? We could then go down and, for example, explore. Okay, at time 0.5, people are still largely normal glycemic, okay? So that would be one way, ladies and gentlemen, that we could set this model up to go to the, to run it for a certain amount of time. This one also will run it till the next thing that has to be done in the model, or 0.1 time, I think, maybe minimum. I'm not sure why by default it's 0.1. In any case, this can also be useful for advancing the model in a very controlled way. Another point about these menus, sometimes you won't find the ones that you like, and there may be things that are hidden on here. You can always, if you have this at the top or bottom, you'll find these kind of customization buttons where you can add in and eliminate things here. Okay, what's shown here is also given in the experiment. If you go down and you look here, it's also given in this window area here. Okay, model navigation, for example. It'll tell you what it's showing initially. And it'll ask you, do you allow zooming? Do you allow panning of the model? Okay? So, ladies and gentlemen, okay, so right now we can go, in short, inspect what's going on, but it's fairly inconvenient. It's fairly crude way of inspecting. We can kind of go and say, okay, where are these different people in the population? I would like to set it so that visually they have a clear appearance. How am I going to do that? Suppose I wanted it so that they have, in their normal glycemic state, they're green, otherwise they're red for diabetic. How could I do that?
Entry actions.
Okay, I love it. I love it. So yes, this is going to require a little bit of education on people's part. You'll notice, ladies and gentlemen, for each of these states, there's certain information we can specify. And one of them is what's called an entry action. When we enter that state, or when we leave it for exit action, we can undertake some task. So what we're going to do, ladies and gentlemen, is we're going to put in place a mechanism in the form of a variable that's going to communicate the color for the person, okay? It's going to, when they change state, it will change that color to be used. Are we okay with that? Okay, so let's pursue this, ladies and gentlemen. We are going to add in to our model a variable. Now, a variable, in contrast to a parameter, is going to be something that varies over time. A parameter encodes some assumption and communicates that assumption from the point of creation to the object that has that parameter in it. So main communicates a parameter to main, experiment to main, or if person has a parameter in it, it's communicated to it, say, by the population in which that person lives. By contrast, ladies and gentlemen, a variable's job in life is not to encode or to communicate an assumption. It's to keep track of some aspect of model state. Okay? So we're going to go to person, and we're going to go to the palette, and we will go to the agent area of the palette. Okay? And there's a thing called variable here. And we're going to drag it in. And this variable will be called color in an appropriately named fashion for British English. Okay? Okay. I always have fun with this in the States. Okay, so color, okay? Okay, and the type of this variable will not be one of the built-in types there. It'll be other, and its type, unfortunately, ladies and gentlemen, is dictated by the strictures of the American Imperium. Okay, so it's going to be color with a capital C. Why capital? Well, it's because it denotes a set of all possible colors. It's a class. It's not a particular color. It's a set of all possible colors. Hence, we capitalize it, just like we capitalize person, capital P. If we refer to a particular person, we might use lower p, lowercase p, but here color refers to a set of all possible colors, capital C. Okay? Okay, so ladies and gentlemen, we have this variable called color, and it is of type capital C color. By type, I mean, what are the possible values it could take on? From whence are they drawn? They're drawn from, they're instances of capital C color. They're drawn from the possible colors with a capital C. Okay? This is a class, and there'll be many instances: black and blue and red and cyan and magenta and lime green and gray, etc. Okay? So color. Now we're going to give it an initial value. A variable has an initial value, not a default value, an initial value. The default value for parameters is just if you don't specify what to assume for it, use this expression. An initial value is what does it start off at? And we're going to use black. Black, ladies and gentlemen, like Conrad. Okay, so B-L-A-C-K, okay? Okay, black.
And that's lowercase.
That's lowercase because it's a particular color. It's a specific color. Color with capital C refers to colorness, colorhood, much like person refers to personness, our theory of personhood in the model. Okay? Okay, ladies and gentlemen, these are Java conventions of the Java programming language that AnyLogic inherits. Okay, so it's a capital B, black, or sorry, lowercase b for black. Okay, now we're almost done. Almost done, ladies and gentlemen. But to get it wired up initially, I am going to now set it so that color, the color variable, changes as we change state. So when we're normal glycemic, I want to set the color variable to be green. Okay? So for the entry action for this state, I'd like you to set color equals green. Now I'm going to put something here that's going to be mighty displeasing. I'm going to put something here that might cause you puzzlement. I'm going to put in a semicolon. Now, there's bad news and there's good news, ladies and gentlemen. The bad news is that Java, as a member of the C family of languages and the family of object-oriented and imperative languages more generally, is afflicted by the cancer of the semicolon. Okay? It has semicolons. The good answer is there's a very simple rule for when you're going to use a semicolon and not. And most people don't know it, who are new to AnyLogic, and they will often flail. They'll insert a semicolon, and if it complains, they'll take it out, and vice versa. Okay, so it's a very simple rule. To this point, we have been unafflicted by the semicolon. That's because we've been specifying formulas which calculate values. If you are specifying a value, you're just specifying a value for a thing, a formula or a number. You don't need a semicolon. It's just getting a value. It's when you have a command, an imperative, you say, do this thing. That's when we need a semicolon, okay? In this case, we're saying, do this thing, make color green. And you can think of it almost like an exclamation point, do this thing. It's a command, so you need a semicolon after it. And that rule, if you apply it consistently, it will deal with this issue in a very handy way. So these rules are called statements. That's how we call commands. It's called a statement in Java compared to a formula, which is called an expression. Okay, so if you have an expression, if it's just calculated value, no semicolons. If you're telling a command, you need a semicolon. Okay? Are we okay with that? Okay, so we said color equals green for that. So when we enter this, this color variable will be set to green. And for the entry action for diabetic, we're going to set color to equal red. Okay? Set the red color. Now, to be consistent, it's in no way operational. There's no enforcement of it. But I'd like to set the fill color for this state to be consistent with this. So I'd like to choose a red color here. Okay? It has no bearing on how it will look when running or how it will change when running their color visually, but I'd like to set this to be red, and this one I'd like to set to be green. Alan has a considerable interest and experience thinking about the aesthetics of models. Models are communicational tools. I was having a fascinating discussion here with Dina during the break, and one of we're seeing a sea change in how models the options available to us in modeling projects for sharing models, and for taking a model that has erstwhile been built only by the modeler, and instead having it be an artifact that's manipulated by a larger team, that's run by that team, scrutinized by that team, critiqued by that team. And this is something Winchell has been leading a great deal with his work with Alberta Health Services. And they've been extensively running his model that he'll probably show you at some point here, and using it to change, identify issues with the model, etc. And in general, we'd like to encourage that. It's one of the reasons we use AnyLogic. It's to allow us to share with team members the model so that they can run and help improve it. And that's something we've made use of extensively with our work also in Saskatchewan with the Ministry of Health. Appearances matter. Traditionally, where you've had modelers squirreled off in some back office, writing down on blackboard and pieces of paper, writing some equations and solving it and giving some report, there hasn't been as much need to use models themselves as a tool for communication. Now that we're seeking to share models within teams and even beyond, we like to be able to pay attention to the aesthetics of models. And Alan has been giving this some significant thought. How do we have models that are communicative, that help make themselves more transparent, help lower risk of misunderstanding, help seem more inviting so that people are encouraged to explore. So ladies and gentlemen, green and red. I made this lime green because I saw it easily there. But if you want, you can choose it elsewhere. Okay, so yes.
Do you have to specify an exit action, or is that only
No.
if they change within the state?
Great question. So you'll notice you have the option of specifying an entry and an exit action. It's not like you have to specify both together. There are times where it might be convenient to specify an exit action. It might be. If you want something of significance to happen when someone leaves a state, maybe you want to write a record to a database for reporting. Maybe you want to save a file, save some information to a file. Maybe you want to report something visually so that someone's aware that there's been this change. You could use an exit action to do that. But entry actions and exit actions are often used independently of one another, in the sense that certain things will just be more convenient to do when you come in and certain things when you leave. Okay, so it's not like you have to do anything there. Okay, you'll notice that in this case, person comes in, we set them to be green, come in here, set them to be red, and really they'll go, when they leave this, they'll go immediately into this one. Okay, so really they'll change directly from green to red. We do have some latitude for where we specify certain things, and as we'll see soon enough, we'll specify some things as actions for these transitions as well. Okay, ladies and gentlemen.
Take a break for a few.
Oh, thanks. Okay, thank you very much. Okay, ladies and gentlemen, I'd like to go to now set it so their visual appearance depends on the color. And one of the reasons I like to use this appearance here in person is because there's a little bit more texture to it. So yesterday, we were able to specify the color for that oval. You may remember, I mean, I'll drag it in here. Don't do it for yourself. Don't do what I'm about to do. I'll just want to show you this principle. If you go here and you go and you look, remember yesterday for this guy, we were able to just say, make the fill color a certain color. Do you remember we had this thing, if my sex equals male, make it, gray, otherwise make it yellow. Remember that? So we're so simple with this guy here. Unfortunately, it doesn't directly support that. There's no place you could set color. But there is a way to do it, and I would like to show you how, and I'll teach you a principle in the meantime. It turns out that that this guy is itself a composite object. And very important principle. Often it's more convenient to reach certain things in the canvas, particularly as you add things to your model over here through the projects window, through this hierarchical depiction. And I'd like to go to person, and I'd like to go to presentation, and you'll notice there's this thing called person, which is this little person here. And you'll notice if you expand that, there's something called shape body, which has a singularly cryptic name. But basically it's the shape that forms the body of that person. Okay? And it has lots of kinks in it and so on, so that hence it's like that. Ladies and gentlemen, we could select shape body, and having done that, we could go to its appearance in the properties window, and there will be something called fill color. And how do you think we're going to specify a rule for fill color? Right now, we're just picking it from a list. Does anyone remember what do we need to do to not have this as a list, but instead to have it as to be able to put in some code, an expression?
So, item state equals. There you go.
Yeah, we need to do this dynamic variable value. And now, ladies and gentlemen, the formula we will put in, the so-called expression that we will put in, will be singularly simple. Where can we find the fill color?
In the variable.
In the variable indeed.
Oh, okay.
We just put in color. Okay?
What is the advantage to doing that with a variable as opposed to just set fill color of the shape body with coding? Is it just that you don't have to do that, or is there something deeper?
Yeah, there's, thank you for asking. There's three basic ways of accomplishing this. And you're alluding to two of them. There's a third way. One way I could have don't do this. You could just keep it like that. But one thing I could say is I could ask diabetes state chart dot is state active, and I could ask, are they normal glycemic? If so, use green, otherwise use red. That would be another way. This gets really cumbersome if you have more than two states. Yeah. Now, I could call a function that will return a color. That would actually be a fourth way. I could call a function that will compute one, but we'll get into functions later. the question is, why is it variable rather than directly setting the color? Excuse me. Setting the color for the shape body, it'll be a little bit more wordy to include in the code at many places, and as such, it might not be quite as clean and transparent to a non-programmer compared to setting a variable and then the variable is just used. On the other hand, it might actually be slightly more performant, but that needs to be, in other words, slightly more efficient, but that needs to be taken into account that it's not going to be a bottleneck. In other words, when you're thinking about performance of a model, typically there's one bottleneck or one or two bottlenecks that are taking the most time. And then there's going to be some things which are just minor issues. And it's really not worth sweating the minor issues, sweating the small stuff. So in this case, I don't think it's going to be a big performance hit, but it would be probably slightly more performant to set the color of a shape body in the code itself. Okay. Now, I prefer models which are cleaner because I like them being able to be looked at by diverse stakeholders. I like to be able to share them with my partners who are clinicians or who are public health officers, etc. And so I tend to err on the side of a model that has simpler code. But any of these are acceptable solutions. And honestly, I think the trade-off between them is pretty minor in this case. Okay? Okay. Now, for a didactic reason, I prefer not to teach setting it directly in the shape body because I think it's a bit more confusing to students. Yeah. Okay, ladies and gentlemen. So we have set this to be given by color. Note that this is declarative. In other words, it's going to be periodically looking at color and updating its color accordingly. We just say color and it will make it happen. We specify the what we want and it will take care of the how, as is any logic's general philosophy for many things. Okay, so ladies and gentlemen, here we're going to run our model. How did I run this? I did this via that. Run it, and suddenly we have everyone turning what?
Diabetic.
They're turning diabetic en masse in a way that is enough to send shivers down PHAC's spine.
We're not going to learn from this model.
No. So, ladies and gentlemen, at least not about that side of things. So, we are going to investigate why this is. Well, right now, if we look at why, it's because everyone is set to go from normal glycemic to diabetic in an exact time of 1 year. That's what this timeout means. Now, please recognize that a timeout transition is just one of about 5 types that are very common. Okay? We're going to go through different types of transitions in the course of the day. A timeout transition, ladies and gentlemen, occurs after a fixed time. Now, please mark my words, because this is a very important point of understanding. Just because this fixed time is right here given as a number doesn't mean it needs to be a number that you hard code in here. Yes, it could be specified by the value of a parameter, but what I'm getting at is it could be specified by a number that you calculate, like by a draw from a distribution. So you might, for example, Winchell back there, perhaps even as we speak, is working on a model for flu using data from smartphones. And actually, it's for a bunch of different conditions. And he might have a timeout transition where this is drawn from a beta distribution. Okay? So, or perhaps you want to draw this from a truncated normal distribution. Okay? Or maybe you want to draw it from one of these other distributions supported by any logic. The point is, that this timeout can be, they will leave the state after a certain amount of time as given by whatever formula is given here, whatever expression. And in general, it may be valuable to specify a timeout whose value is drawn from a distribution. Okay?
Sorry, we're not getting power down the center of this bar.
Okay.
Does that have enough room?
This one's got a lot more room.
It has.
Okay.
It's still not lit.
Okay.
If you bring that one over, maybe it'll.
No, I'm not getting power either, I guess.
Hold on.
Could it
Is that working?
Winchell, could you investigate the power situation up here?
Now you have it? Okay.
Hers is also not working, so it's working.
Is it working now? 'Cause it
They
says
seem to work on the
master.
outside, but not down the center.
Yeah.
So you're not getting power?
I'm not getting power.
Okay, so Dina's plugged into your power?
Yeah, so that center one is not working. So this one
So
is,
you might want to try this one here, this bar.
Here.
Is there space on it?
the other this side controlled by master is working, but not this middle
Yeah.
one. Do you have power now? Check it now.